Hello, welcome to our channel for probability and statistics. In this video, we will talk about hypothesis testing on two proportions. So very often, data analysts wants to test the hypothesis that two proportions are equal. For example, we may want to know if the proportion of smokers with lung cancer exceeds the proportion of non-smokers with lung cancer. So usually from these two populations, we take some independent random samples from both populations. Then we test the proportion in the sample for these two populations, right? So the hypothesis for the population is we test P1 equals P2 against one of alternatives, P1 less than P2 or P1 larger than P2, or say P1 not equal to P2. So this is alternative hypothesis. And this is equivalent to testing P1 minus P2 equals 0 against one of alternatives, P1 minus P2 less than 0 or P1 minus P2 larger than 0, or say P1 minus P2 not equal to 0. So from the sample, we based on the decision is a random variable P1 hat minus P2 hat. So P1 hat, P2 hat are the proportions of success in two samples, right? So when N1 and N2, where both are the sample size sufficiently large, or say at least 30, so the point estimate P1 hat minus P2 hat was approximately normally distributed with mean. So mu P1 hat minus P2 hat equals the population mean P1 minus P2. And because these two samples are independent, so the variance of the P1 minus P2 hat equals P1 Q1 divided by N1 plus P2 Q2 divided by N2. So this in the numerator are population parameter. So Q1 equals 1 minus P1, Q2 equals 1 minus P2, right? So therefore, we can establish a statistic, which is a standard normal variable. So this variable equals P1 hat minus P2 hat, then parenthesis, then minus parenthesis P1 minus P2. So the sample proportion difference minus the population proportion difference, then divided by the square root of their variance has standard normal distribution. And this statistic usually will be used to calculate the critical region, right? So if H0 is true, so which means if the population proportion is true, is equal, P1, P2 is equal, so equals P, and Q1, Q2 equals Q, then we can transform this value as P1 minus P2 hat divided by the PQ and times 1 of N1 plus 1 of N2, take a square root. So this statistic will have standard normal distribution. And because we have no, in the denominator, we have no such information for the P and Q. So usually we get this P hat from the sample. So this is called pooling data from both samples for the success rate. And where X1, X2 are the numbers of success in each of the two samples, and we substituting P hat for P and Q hat for Q, which Q hat is 1 minus P hat. So P hat is the pooling sample proportion. If we assume these two proportions in a population are the same, right? So the Z value will reduce to this form: P1 hat minus P2 hat divided by P hat Q hat then times a fraction of sample size and take a square root. So this statistic will have approximately standard normal distribution. So next we will take a look at the sample. So vote is to be taken among the residents of a town and the surrounding country to determine whether a proposed chemical plant should be constructed, and to determine if there is a significant difference in the proportion of town voters and country voters favoring the proposal. A poll is taken. So there are two samples. The first sample from the town, 120 of 200 people favor the proposal. And for the country residents, 240 people of 500 sample size favor it. So the question is, would you agree that the proportion of town voters favoring the proposal is higher than the proportion of country voters? Use an alpha equals 0.05 level of significance. So the solution is the first. We will let P1 and P2 be the true proportion of voters in the town and the country. And we establish null hypothesis H0 is P1 equals P2. So this is the population parameter. And alternative hypothesis is P1 larger than P2 because the question is favoring is higher. So which means the analyst has excluded the case that P1 is lower than P2. So we do not consider the case that P1 lower than P2. So we only consider if it is higher than. So this is a one-tailed test or one-sided test, right? So which means we consider alpha is 0.05 and critical region Z equals 1.645 for the normal distribution if leave the density probability 0.05 at the right side. So we just think if the test is larger than this number, because standard normal distribution when the variable is 1.645, so the probability of larger than this critical value is 0.05. So we will test if the data from the sample gets statistic larger than this value. If larger than this value, it will be significant, right? So we have all the information. P1 hat 0.6 and P2 hat 0.48 and the pooling P is 0.51. Then we just fill in all these numbers in the formula for the Z statistic. We'll get Z statistic 2.9 and we get a p-value of a standard normal distribution if variable larger than 2.9 is 0.0019. So you can see this Z value is much larger than 1.645 and the p-value is much less than 0.05. So the test is very clearly significant and we have a decision. Conclusion is reject H0 and agree that the proportion of town voters favoring the proposal is higher than the proportion of country voters. Thanks for watching.